problem 16, chapter 18, Giancoli 6th edition. So we have a certain copper wire with this resistance here, 0.10 ohms. Okay, and we want to know at what point along the length of this resistance should we cut the wire so that the resistance of one piece will be 4 times the resistance of the other. Okay, so here is my wire, so let's make a drawing here. Okay. And I want to know, well, remember, what does the resistance depends on? Depends on the material, depends on the length, and on the area. I'm not going to change the material, I'm not going to change the area, I'm just going to change the length of this wire. So I'm going to cut this wire at a certain point. So let me say I'm going to cut it somewhere here, so that this new resistance R1 of this smaller wire is smaller than the resistance of the other piece R2, where this bigger one R2 is 4 times the smaller one. Okay, so that's what I want to know, and I want to know now where should I cut? What should be this X here? Okay, remember the whole length is L. Okay, so how am I going to do this? Well, I want the R2 to be 4 times R1. R2 is going to be rho. Now instead of L, I'm playing with L minus X divided by 4. And what is R1? R1 is rho, not the whole length, just X divided by the area. Okay. Now we know that R2, the resistance of the bigger piece, is 4 times the smaller one. So I'm going to write this rho L minus X divided by A. This is the bigger resistance, is equal to 4 times the smaller one, rho X divided by the area. So many things will cancel here. Let's cut this resistance that doesn't change, this area that doesn't change, and now from here we'll be able to find what is this X, right? So I just need to solve this equation, and what we'll see is that 5x is equal to L, so X is whatever length I had divided by 5. Okay, so I know that where should I cut? Well, here at 1/5 of the total length. That's it. Now comes the next question. What is the resistance of each piece? Okay, so I have here the resistance of R1 is this. Okay, so R1 is rho. X, I just found what X is 1/5 of the whole length divided by the area. Rho, so I'm going to isolate this 1/5, and then I have rho, length, and area. Well, this whole thing is the original resistance, which for me was 0.1 ohms. So here you just see that the new resistance of this small piece will be 0.1 divided by 5. Okay, for the large one, R2. R2 is rho. Now L minus X means L minus 1/5 of L, right? So L minus 1/5 of L divided by the area. 1 minus 1/5 is 4/5. Okay, so I have 4/5 here, and everything rho L A is what gives us the original resistance. So you see that the new resistance of the larger piece will be 4/5 of the original one, 4/5 of 0.1 ohms.